Welcome back to Basin Quest. Now, this is the third post of the series wherein we embarked on building an object detector from the scratch. Now, in the first post, we discussed about different techniques of object detections like your RCNNs, the YOLOs, SSTs, etc., etc. And we just saw in general the complete genre of object detectors. And in the second post, what we did was we built our own data sets, the pothole detector data sets from the scratch. Now, in the third post, in this post, what we're going to do is we are going to build the object detector from scratch. Now, you might wonder, why do you have to build an object detector from the scratch when you have much more sophisticated techniques like your RCNN, YOLO, your TensorFlow object detector APIs, or SSTs, or even visual transformers? Why do you have to build it from the scratch? Well, the answer is quite simple. Now, once you build something from the scratch, it helps you to understand the nuances or appreciate the nuances better. And when you get into advanced techniques like your RCNNs, YOLOs, visual transformers, etc., you will be able to customize them much better when you understand the nuances when you build it from the scratch. And by the way, we are going to cover these advanced techniques in the future post in this series, like your RCNNs, YOLOs, SSTs, etc. So brace yourself for an exciting journey in object detections. Let's dive in. Now, before we build the classifier, let's load the data from from our disk. We had saved the data, and then look at the features and the labels. Now, this is how we load the data. So read is the read. Now, DB is the database, or H5 database. So DB pothole features, that's the name which we have given. See, pothole features all is the name which we have given. And the first one, the first index is the labels. Earlier I said there are 8209 features for this. So the first one is your labels, and next 8208 is your data, or your actual features. So first one is the label and the other is features. So that's what we store here, data and labels. And let's look at and you close that database, and then let's look at the shape of the labels and the data. So you have 730 into one dimension of labels. It could be either positive one or negative one, and the features. So 730 examples, 310 plus 420, and 8208 features. So using the 80 into 40 window size, I got 8208 features. You might get a different type of features if you adopt a different type of window size. So next is to run the model. I'm using a SVM. Why SVM is because traditionally image pyramids and sliding window used to have, or was being used through using an SVM. You're free to choose any kind of classifier which you want. So maybe I would suggest you to try out different types of classifiers. So you build the model. I've already built the model, so I'm not running this file, but this is how you build the model. As we see, you give a linear kernel and define your C parameter. Here probability is true. You need to get the probability, not the class files. Just giving a random state, and using model fit, you fit the data and the labels, and then you store these or save these model as a pickle file in your path. So you'll have so once you run this, you will have this the pickle file stored. So now what we have, let's just look back at what we have done so far. So we have taken the positive classes, negative classes, done a lot of augmentations, and then we extracted features, saved it in a database, made it a S5 database, and then using the database we have built a classifier also. So now next is the step of what we are doing is the inference process. The inference process is using the classifier which we have built and the new and the images which we have got, or test images. Now we are going to look at the predictions of bounding boxes. So that's the inference cycle. So here is where we use these techniques like the image pyramids and sliding windows, which we have seen in the earlier post, that is post 1. We have seen that what is an image pyramid and what is a sliding window. So if you have not seen these, please refer to the post 1 of these of the series. So where the image pyramids and sliding windows are defined. So now we'll see implementation of these image pyramids and sliding windows.